Nope. Hello, dearies. Welcome to Undersampled Radio, episode 85.
85, that's what you settled on.
If you're not watching the video and instead are listening to this podcast as a podcast, you have to take note that we, and by we I mean Matt, Diego, and myself, are in Houston.
We're all together, all in one room.
You can say something too if you want, Diego.
Yes, we're all together.
Thank you.
They're not lying. I'm here as well.
We contemplated recording this episode at the library / the bar and decided that this office would be quieter and more conducive to our soothing baritones.
Yes.
Thank you. Okay, so before we get started, we're going to try this. So,
Right.
This is apparently a chocolate bar
Authentic.
brought to town by some of our employees in the Romania office. I've been told, and they absolutely may be pulling my leg, that you probably can't read this, but it says ROM, R-O-M, is the, thank you, is the word for rum, like the spirit. So I assume that these are sort of liquor infused chocolate bars or something. So we're going to give this a shot.
Yeah.
Before we get too deep into, thank you, the auditory experience of unwrapping the. Oh my God. Okay, it's not. It smells.
It does.
Smells alcoholic.
Yeah, it does.
Okay. Oh,
there are no English language ingredients, so we'll never know.
Oh my goodness. It's filled with a.
Oh wow.
It's filled with some sort of.
I feel like we should have a few and then continue with the podcast.
The problem is that we eat that much sugar, we're going to be bouncing off the walls. It's
That-
actually pretty good.
That is rummy.
It is very, very spirituous. It is, it's dark chocolate.
Mhm.
Man, it's good.
Yeah, 1.9% alcohol.
Is it?
Yeah.
Wow.
It does say that?
Yeah. Oh, these are delicious.
How many languages do you know?
I can do numbers in most languages.
Okay, so
Thank you guys for
we're on
tuning in.
in. Thanks for joining us. We'll see you next week.
We're quite chewy. A little bit hard to speak while you're eating
Okay,
them.
you chew, I'll speak, and then we'll trade. Okay.
Especially as I'm slightly concerned about my throat. I ate that sweet a strepsil before this. It's not a great combination of flavors.
I have a travel toothpaste with me too. If you want to just squirt some of that in there.
Yeah.
Yep.
That would continue in the right direction, but it turned my entire mouth numb. So this is only adding to that experience.
So we didn't write any show notes. If you're looking for them, you won't find them. Instead, what we actually maybe we'll take a photo of this whiteboard.
The show notes are right there.
That Matt has written down for us and post that on the website, which is undersampledrad.io. I just found out not 30 seconds before we went live on this show that the softwareunderground.org website is revamped, revitalized, rejuvenated, resilient, and it's pretty awesome. So what's on here? All right, so I'm browsing this site live, softwareunderground.org. There's a way to join the Slack group.
Yeah, and that's
check out all of our favorite books.
I know.
That's awesome.
It's pretty cool.
Where do the books come from? Are these suggestions from people on the reading channel?
They were suggestions, exactly, yeah.
Are they updated automatically by a bot on Slack, which they should be?
That would be amazing.
Yep. But
thank you for volunteering. No, they're not, but that would be really cool. I wonder if they've been updated recently. Are the 52 things on there? Because Matteo wanted to add them. Matteo, I'm checking up on.
No.
Yeah, come on, Matteo. Like this was the deal. So anyway, those will be on there soon too as well. And I think I've got a couple of other suggestions to add. I just wanted to mention though, for the Slack, because one of the tricky things about Slack used to be that you had to invite people individually to join it, or you could say, no, everybody with this expero.com, agilescientific.com email address can join.
Mhm.
But now you can do a new thing. I don't know how new it is. This could have been around for ages, as far as I know. But you can do a new thing, which is say, this is an open Slack. Please give me a special page that people can go to sign up. And I used to manage that with a little Heroku app, which people could.
I remember that one.
Yeah, and it went down last week for whatever reason, and so I poked around to find a new way, and it turns out Slack have got a way now. So if you happen to have your own public Slack, or you were thinking about starting a public Slack for an enthusiast group or something, that's kind of a neat new feature.
So is the swung.rocks, okay, it just redirects to softwareunderground.org, because in the intro audio to this show, it says visit swung.rocks.
Okay, does it? Right.
Which is cleverly redirected to this
Yeah.
site, so you can still use that link.
Through the magic of however it is computers work.
Yes, there's also merchandise on here. What's in merch?
Merch.
T-shirts
Mhm.
and mugs.
So far, only a t-shirt and a mug, but more coming soon because we just experimented with the orange colorway on a black t-shirt. Actually looks pretty sharp.
Ready
I'll be
for
wearing
Halloween.
it later this week. What?
No, I was going to say ready for Halloween, but maybe it's too early.
It's a little bit early for Halloween, but we will be ready when Halloween comes. If it comes early, we'll still be ready.
Right.
And a mug, a very nice mug. The mugs actually look pretty sharp. I haven't seen it in person yet, but they've started arriving in people's hands. There are a couple of photos on the Slack. So
it's
check them
happening.
out.
Yeah.
It's happening. And those do support your Software Underground Slack subscription fee. So
wait, so you're telling me you can subscribe to Software Underground now?
This is a shakedown. Oh, yes.
Yes. That's also on the website. And if you buy a mug, it contributes towards your well, I guess it's money that goes to Software Underground.
Yeah, exactly.
Okay, so that's cool. Anyway, the site looks good, so good job. Did you write it?
Yeah, it's a Squarespace site.
Okay.
Squarespace.com. All your website needs. It's a Squarespace. Where did that come from?
Also,
it's just like agilescientific.com is also a Squarespace. Squarespace.com. All your website needs.
I wonder if
one of those
Squarespace
awesome
is maybe
sites.
the only company that we haven't pissed off on this show. If Squarespace is looking for sponsorship opportunities.
Yeah, I think a lot of people are disappointed when they find out that, because some people think of me as geeky. I'm really not as geeky as I seem, but
You're more.
All right, maybe, but they're really disappointed when they find out that I use like the most packaged, user-friendly website experience, hosted, managed CRM that you can lay your hands on.
Yeah.
I don't really have a follow-up sentence to that, but all I want to say is I don't want the headache of like running my website, having it go up and down and having to maintain all those bits.
What is this damn show called? Run this chocolate bar, man.
Yeah, I can't remember. It's
no. It's Undersampled Radio, I believe.
Yeah,
is also a Squarespace site.
it is.
But my other websites, including my old business and my personal, are just handwritten, and they are a pain in the butt to manage.
Right. What you mean? It's like you've written the HTML.
Yeah.
It's static.
By hand.
Yeah.
All right.
Nice.
Yeah.
That's cool. And how do you host those pages?
On a Raspberry Pi somewhere?
No, I have a VM running somewhere.
All right.
I don't know. I should probably go touch those websites because I haven't in years. Literally,
or a Russian hacker does.
They've already been taken over.
That's okay. No secure credentials harmed in the attack of the website.
Yeah, you might just want to check your TMP folder.
Yeah.
On that server. But yeah, no. Someone asked me the other day actually, like they wanted to learn, or one of the things that she wanted to do with her Python skills was build a web app to sell like merchandise on a e-commerce site. I'm just like, don't do that.
Yeah.
That would be super hard handling credit, right, Diego? Credit card transactions,
although it was,
user accounts.
Yeah, it was. I think the real issue would be if you have an inventory
management.
Yeah.
Like,
That
don't
is a-
make
that
that
is a
your
mess,
first
yeah.
web app project.
Yeah. If your product is not, it's a digital product, then it might be easier. Like Stripe, what we
Right.
did with events was in the end fairly easy to implement.
Right.
We've used Stripe too in the past for various projects. It's nice.
Yeah.
Stripe is awesome and completely integrated into Squarespace.
What is this?
Sorry, but it is. They handle it really nicely, right alongside PayPal. So on the Software Underground site, you can pay credit card, PayPal.
Venmo.
I beg your pardon?
Venmo.
No, I don't know what Venmo is.
PayPal owns it. It's just like a slicker version of PayPal.
Okay, well then you need a slicker version because PayPal is super clunky.
Yeah, just download Venmo and send me some money to test it out.
Okay. Wait.
Hey, I just thought so it's kind of distracting for me. The video camera's facing us and the screen is facing us so we can see ourselves. Check out my shirt I'm wearing. It is and so what I was thinking while I was watching myself is I came up with another idea for someone to have on the show.
Okay.
And maybe I just won't say his name in case he's not interested, I guess.
Yes.
But anyway, he's a person that works at this company called Pelosa, the shirt I'm wearing, which is a distributed bitmap index company.
Oh.
Let it sink in.
Okay.
Distributed bitmaps.
Index.
Okay.
Anyway, I didn't know anything about bitmap indexes at all until I started speaking with these folks, and they're pretty stinking cool.
Tell me what that means, because it
Is this
sounds
like some-
cool, and
Yeah.
I think I know what I think it means.
Okay, so
But
let me
what do you think it means?
let me mansplain this to you because I don't know what I'm talking about. My understanding is that a bitmap index is a map from in the most simple case from like categorical data into a 1D array or whatever of bits on and off. So ones and zeros. So you can imagine if you only had categorical data, you'd be one-hot encoding data. And because you have this very structured representation of your data that's only got 2 states, it's extremely fast to select out of that data structure.
Okay.
Like hundreds or thousands, or what I'm sure you can find on their website what the claim is, but many orders of magnitude faster than searching through a relational database or something like that. So
Interesting.
these people are, I guess all commercial bitmap indexes, that's the right
Indices.
plural. But it's an index, multiple indexes, not multiple indices in the same index.
I know what you're saying.
Anyway, so they can handle data that's not categorical data. Like they can, in some cases, they can deal with like limited values of floats, and they can deal with time and whatever.
Okay, that's not what I thought you were going to say. So that sounds interesting.
And then this one is distributed, so you can also deal with big data. But anyway, there's
another Austin company?
Smart, yeah. But there's a super smart guy I've gotten to know there, and he would be interesting to have on the show. So expect me to take action on that at some point. Cool story.
I will.
But while we're on the story, let's go.
Is this a segue happening?
Because
glances over to show notes on whiteboard.
The whiteboard show notes. What's first? What's next? What's EAG hackathon happened?
Oh,
Didn't we
right.
talk about that?
No. Well, what do you mean?
Yeah,
That
last
it was
show.
happening.
Huh?
We talked about that it was going to happen.
Oh, and it did happen.
It just happened at the weekend.
Oh.
In Malaysia, Kuala Lumpur. So organised by EAGE with some help, I gather, from a local company that I can't remember the name of, but they basically do machine learning stuff in KL. Excuse me. And Microsoft apparently showed up with a substantial number of people and offered their platform, so people were running stuff on Azure, et cetera, and our friend of Software Underground, David Holmes, was there from Dell EMC, and he was reporting back on the sort of back channel with some pictures and stories and stuff, and it sounded like it went really, really well. Like, you know, he was positively encouraged and surprised at how awesome it was. So it's not much of a story, but I thought it was cool that it actually happened. Loads of people showed up, some vendors showed up, people built projects, and fun was had. Apparently they told people to bring sleeping bags so they could like crash out in the hallway. So I don't know exactly how that bit went. That sounds like a sort of legal insurance nightmare, but yeah, pretty cool.
So next EG, bring your sleeping bag.
Ugh. Get kicked down in the San Antonio Convention Center. No thanks.
Are there any other events coming up soon? Maybe this week, a couple days?
Yeah, that's true. I don't know how you remember that, but there is a Software Underground meetup happening. Yeah, on Thursday at the Platypus Brewery.
You might want to mention the date because this episode probably won't come out for like 3 weeks.
It's Thursday.
Our editor's pace.
Okay, so if you're listening live, Justin,
you have a chance.
It's Thursday, the 28th of February.
And if you're listening to this as a podcast, you missed it.
Yeah, no, but there will be another meetup in Houston next week, because next week it's also the HPC, the Rice HPC for Oil and Gas conference happening in Houston.
Oh, I went to that last year.
Okay. It's happening again.
It's happening again.
Next week?
I believe so.
Oh.
Yes. And because so the DeVito folks, or at least Gerard Gorman, is coming over for it.
Yeah.
And so he was asking about a meetup, and Evan will be here teaching with John Lehman of Don't Panic fame, teaching a public class here in Houston. So there'll be some kind of meetup next week as well. So that's the first week in March. It'll probably be like the 6th, 7th of March, somewhere in there. That's all I got.
Cool.
Event-wise.
I've been to one Houston swung meetup.
Ever.
And yeah.
There may only have been a couple. I don't know. Have there been a few?
I don't know.
Okay.
I don't live in Houston.
No. But there should be an Austin one too.
Are there other Austinites on swung?
There's got to be.
I will organize that. Let me take a note.
Yeah. That'd be fun. There was one in Calgary a few weeks ago, and it was cool. People came along. You were there, Diego. Why don't you describe briefly what happened? I forgot you were there.
We just got together on a pub that happened to have a nice little space in the back with a giant TV with a dangling HDMI cable. And yeah, people were just eager to tell you mini stories of cool, interesting things that just happened.
What was the coolest thing that anybody showed?
My stuff, Docker based. No, I think it was different enough. Like that, I don't know. Everything sounded like interesting to me, at least. All of this, I still feel like it's new to me, so it all looks interesting.
Yeah.
So there was definitely like I'm really bad with names, so I don't remember most of the names of the people I met except Evan, because I work with him.
Yeah.
And so, Matteo showed us like some really nice notebooks that he made as part of tutorials, and I think they're basically about how to display properly some types of data structures and files, and the fact that we could plug in a computer to basically have the Jupyter notebook available, like made it so that it was a bit more engaging than just talking about it.
Yeah, right.
So there was okay.
There's actually a little bit of, not structure exactly, but yeah, a little bit of knowledge sharing, spontaneous knowledge sharing happening.
Yeah. So
good idea.
Yeah.
So yeah, but there was no plan, like there was no list of people who had to present anything. Like if you felt like there was something cool that you saw and that you could show people, then you just hooked up your laptop and talk about it for 5 minutes.
Is that the goal on Thursday?
Yes.
Huh.
Yeah.
That's a great idea.
Yeah, yeah.
The one that I went to is just devolved into spontaneous conversation.
Okay. Well, that's important too.
That's also valid.
Yeah. So one of the things that I said on Swung recently, and connected with the fact that we're now sort of fundraising essentially through selling swag on the website, and also having people contribute sort of subscription money on a monthly or annual basis to Swung. It's completely voluntary, so these are essentially donations. But connected with that, I said that if there are Swung meetups happening, so Software Underground meetups happening around the world, that Software Underground will support those meetups with money. So, like, I don't quite know what that means yet, but you know, if there's a few people getting together talking about geoscience computing stuff, then you know, within reason, Swung will meet those costs, you know, up to some reasonable amount, like $100 or $200 for the evening, that kind of thing. So, like I say, I know that sounds super vague, but you know, until I regret saying it, I'm happy to pay the bill for these meetups. So, you know, if you're somewhere where there's a few of you, you know, not just you, like, I feel like.
Well, I wonder if you could also,
if you're thinking about just going out by yourself, might not call that a meetup. So I think there has to be at least a couple of other people. Then I'm up for supporting that. I'll send stickers and T-shirts.
I wonder if you could offer some sort of co-hosted meetup. It seems like educational institutions or something would be happy to.
Yeah, that's
like
a good
what
idea.
I'm thinking is like maybe UT in Austin, for instance, geoscience division, geophysics division. That what was that thing we're at? BEG, Bureau of Economic Geology. Might be interested in hosting a co-sponsored meetup. I don't know.
Yeah, no, that's a good thought. So yeah, if anyone's got creative ideas about how they could hold a meetup in their department or in their workplace or in their town, then I'm all ears.
And I will be doing it in Austin shortly.
Sweet.
So
yeah.
Except I'm going to invite a whole bunch of people that aren't geoscientists. So also enjoy that.
Yes. Excellent.
All right, let's get down to it, folks. I want to talk interpretability.
Ooh.
Of
seismic
machine learning models.
What is
so disappointed? That could include seismic.
No, absolutely. I keep hearing about model interpretability.
Yeah.
What does it mean, Graham?
It's distracting that you're just petting that fern, or what is that? Rosemary? What was the question?
What is machine
learning interpretability?
Model thing interpretability.
It depends.
Oh, sorry, that rum is.
So, the service that Expero offers, and my concept of machine learning model interpretability is characterized by two different phases of investigation or of like potential product that you could offer.
Okay.
Phase one.
I'm ready.
How does a model interact with its input and output space? So what I mean by that is how does your model respond to its inputs, and where do those outputs fit into the total output domain? So by way of example, we wrote a system that was a credit approval system for small business loan applicants.
Right.
And we write this model, working great, getting super high accuracy scores. The correct business procedures are happening well when it goes into production. One might call it the end of the day at that point and carry on and let that baby run in production. So what happened is we found out that in fact the model was approving 1 in 3 male applicants, but only 1 in 10 female applicants.
Wow.
Yeah. So a huge problem with bias there, right? Okay, so that discovery is one part of the or it doesn't have to be machine learning, actually. Any model could be a deterministic model interpretability, right? So discovery. And then the question for phase 2 is, why is it doing that?
Right.
And can we fix it? So in this case, the answer was that yes, indeed, we could fix the model. And we played some, in this case, proprietary, but tricks with the data to come to correct the bias in the model, so that one in, I don't remember what the actual numbers were, so let's just say that 1 in 3 men and 1 in 3 women were qualified loan applicants were approved.
I see.
In the corrected model.
So what, that involved creating some sort of modeled, simulated data to fill in some sort of classes that were underpopulated, as it were, some areas of the data domain that weren't populated?
That is one technique that you can use to correct for model bias. But increasingly and more interestingly, in my opinion, is the actual manipulation of the latent space of the model. So in this case, we are talking about machine learning systems, not deterministic systems. And you can find all over the place, not just papers, but now actual libraries where you can perturb latent spaces in models. And you can, by doing that, you can actually change what the input domain, output domain mapping is, right?
So you're doing this, so you keep on giving it data, and because you don't know, these latent space parameters don't mean anything, right? I mean,
by themselves.
By themselves,
yeah.
They're synthetic parameters. Is that fair to say? So it's not like this one is like changing how income affects the decisions. This one is changing how gender affects the decisions, or does it turn out to be like that?
No, it does not. So I'll talk now specifically about deep learning, because this is the system that I was mentioning. Only groups of neurons affect things that are human interpretable. So let's shift gears a bit from the loan approval system, which, by the way, the point of that story is, yeah, the model came out to be more fair and ethical, but also more qualified loan applicants were being approved. So also ROI went up. So that's a cool outcome.
But does this imply that your training data was biased to begin with? Like, does this mean that basically what you were using to start?
The reason there was bias in the model in the first place is not because the model was wrong. The model was correct.
It's the data that is
100 years worth of bank operations, right? Yeah. Was the problem. Which is kind of cool, because now that we have a quantitative system in place rather than just human loan approval officers, we're able to correct for institutional biases.
Yeah. Have you read Weapons of Math Destruction?
I have.
Yeah.
Like this was,
I think we talked about the book on the show before.
Like when I was at KDD, I attended KDD last year, I think it was, or maybe a couple of years ago now. Yeah. Anyway, KDD 2017. Yes. Bias, like how to fix, and the problem of like bias in training data for any machine learning is the theme of like now Microsoft research, Google research, like they're all just throwing money at how do you handle this type of problems, because every single piece of data that you have collected is biased.
But again, like that is only one part of the puzzle. Like in most cases, in actual business operations cases, it's not how do you correct that. It's actually just detecting that there's bias in the first place. It's non-trivial. So, have you played with Lucid?
No.
Oh my God. Okay, so I'm sure that you've seen on the Distilled publication the visual representations of latent spaces, right?
Yeah.
So,
I know Lucid.
Yeah. So for those of you who haven't seen this, and also, by the way, check out distill.pub. It is the premium web publication. It's amazing. But there was an article in there. Actually, there are several articles up there by the Lucid team, which is Google sponsored, that attempt to correlate neurons and neuron groups and layers of neural networks to human interpretable concepts. So looking at the The website, by the way, is github.com/tensorflow/lucid. There, you can find some pretty sweet demos of the thing, and they have notebooks hosted up there that you can play with. And there's one up there in particular, which is really fascinating, called activation grids. And you're looking at an image, a whole input image, but it's segmented by neuron groups, and you're actually visualizing pieces of the latent layer, which it is a very cool representation of how the network categorizes images that are input to the network. So again, that's a much more visual and sort of physically understandable way of looking at latent spaces. It isn't that simple in practice, and I mean, when you're dealing with non-visual types of data. But the same principles apply, and there are, I mean, you just search on Google, there are many other libraries that are coming out now to start dealing with this type of stuff. However, I suggest that there is not a silver bullet yet, and there's definitely, I mean, again, Microsoft's throwing tons of money at this, Google's throwing tons of money at this. It's a big unsolved problem, and there's two major facets to the problem. And another shameless plug, it takes a consultant or it takes at least someone looking at this stuff to be able to come up with the answer.
Yeah, no, it's interesting.
So how do you judge like fairness? Because you're sort of like correcting for a bias, but you as a human being are also the one judging that your results are fair, right? So so how do you set that up? Like, do you just
in a business
build
practice, a priori, you know, or maybe you don't know, but you have to make a decision about how you want your business to operate.
Right. So it's all a business decision, basically.
I think that that's a big driver of this stuff. Yeah. I mean, there are certain ethical cases, like the case I just talked about, where it's obvious that something needs to be changed. But bias in models doesn't rear its ugly head every time. You know, it could be something like, for instance, our deliveries to the suburbs of Chicago region are disproportionately low on Tuesday afternoons. Why? You know, so those are also types of bias that you need to uncover and correct for.
Yeah. So just before the show, we were chatting a little bit about that E10 paper, which we can drop a link into the show notes if somehow, if those exist at any point. So this was on the archive a little while ago, and it was about discovering
29th of September 2018.
29th of September 2018. So I think that was after we stopped our phase one of Undersampled radio shows. So we won't have talked about that paper, but basically the authors were trying to test. They made this thing called SciNet, which they deliberately gave well-known problems to, and what they were trying to do was learn, at least the example I remember, I think they did a few, but was learn trajectories. So given some parameters, they wanted to see if they could discover the laws of gravity that determine a projectile's trajectory. And what they did was deliberately allow more dimensions to the latent space than you need to represent that problem.
Yes.
And they wanted to see if, after learning these trajectories, the network had only given weights to the number of dimensions that it needed to represent the problem, and the others would then be zero. And if it did, then we could feel like it had, and if those weights were the same as the coefficients of those parameters in our physical model of that system, then you could feel confident that it learned the same law, right? The same natural phenomenon. And indeed, that's what happens, and it does. So it sets the other weights to zero, and you know, you've got sort of the same parameters with the same weights as our gravity, sort of physical laws.
It also looks like they're injecting a Bayesian prior here in the decoder. So it looks like they're actually injecting an additional piece of information into the second half of the network. And so are they attempting to condition this latent space on the output side? Like, do they propagate backwards this way to answer this question Q? Do you know?
I
haven't
don't
read it.
quite remember how that architecture right there in the paper on page 2 connects to the description, but so I'm probably giving a rather high level and possibly incomplete and/or incorrect description of how I remember it. But what they were driving at eventually was the sort of problem in quantum mechanics where we've kind of shoehorned classical mechanics, into that problem, and it sort of works, but we end up with a whole bunch of paradoxes and things that we don't really understand. So what they want to then do is say, well, okay, if SciNet can discover minimal explanations or sort of sparse explanations for things, and we now throw quantum data at it, what does it discover? Does it also? So I guess that's interesting that you can sort of get the latent space to represent things that we definitely do understand in that situation, and that the other weights end up being 0. So I wonder if what happens when you apply some of those sorts of principles to woollier models, like models of human behavior or models of, because if you can't interpret a weight, then it sort of suggests that it combines a whole bunch of concepts that we're used to, and that maybe that latent space isn't big enough then to represent the problem in an understandable way. Right.
That's an interesting approach to the problem of latent interpretability.
Like, how do you know what the right latent representation is of a problem? Yes, is the question.
There's some, I listened to a data, by the way, if you don't listen to Data Skeptic podcast, it's freaking awesome.
Okay.
There was a Data Skeptic the other day about discovering the upper and lower bounds of latent spaces for particular problems. Did you listen to this one?
I haven't yet, but
yeah, so it's interesting. He, in particular, this researcher was working on an NLP problem, and the question was, as we reduce or rather increase, we start at 1 node in your latent space, and they increase the number, and basically set up an autoencoder architecture and see what the degradation of signal is on the output side as the number of nodes is small. And I mean, I'm sure you guys have used Word2Vec. The standard thing to do is just set n to 300, right? So you have 300 nodes in the middle, with no rhyme or reason as to why. And so this team said, why, right? Yeah. So they started with 1 node, and as I recall, they found that the signal was, the degradation of the signal stopped improving as they got to 19 nodes in the hidden layer, in the latent space, which is weird and arbitrary, but in that particular problem, they were able to sort of empirically show that there is some threshold at which or some lower bound that you need to perform.
Yeah, it's like a kind of complexity space or something that you're.
And the other question is what's too much?
Yeah.
Because obviously 3 million nodes is too much. But what do you, other than maybe nothing other than computational complexity, but anyway, these two teams need to get together.
Yeah.
Let me give you I pulled up, so you've self-selected, if you're listening to this, you've self-selected as an audience that can stand to hear me drone on for an hour at a time. And if you're into that kind of thing.
So with that apology out of the way.
Yeah.
Prepare for the next hour.
Settle back.
I gave a talk at a Texas AI Summit a couple of weeks or a month ago or something, which is on, I believe it is a recording on YouTube. So I'm going to talk about just for 3 or 5 minutes the talk I gave. And if you want to see the figures I'm describing, it's on YouTube. I don't know where it is. Maybe if I can find it, I'll put it in the non-existent show notes.
Yeah, cool. I'll find it while you're talking.
Cool. So this is a similar experiment that I set up, and this piece is just purely a demo for the talk. But the analysis holds. I mean, this is the same type of analysis that you would do for any sort of, well, it is one type of analysis you could do for latent space investigation. So I set up a pendulum I studied physics in school,
Okay.
so we like pendulums. So I set up a pendulum and I measured the motion over time, drop the pendulum, whatever, watch it swing, take measurements. In reality, I just did this on the computer. And then I, quote unquote, derived the physical equation of motion for a pendulum. And I also used the observations and built a deep learning model. So 2 models were derived from the motion of the pendulum. 1, physical derivation using kinematic equations of motion, and 2, a deep learning model. I compared the outputs of those 2 models, just plotted them, which you can see here. And they didn't match up.
They're out of phase, or yeah, different frequency.
So then I plotted in the background the ground truth, the observations. And they matched the deep learning output, but they did not match the kinematic equation.
Okay.
Mind blown.
Nobel Prize on its
So,
way.
but did you take into account for the kinematic ones, like friction and air density and anything that would change
Obviously,
the velocity
someone
of your
studied
pendulum?
physics in school. Okay, so the premise is you have an incorrect deterministic model here, and why is that? And can we learn something about physics by investigating the correct, empirically correct deep learning model? And so what I did was I actually perturbed pieces of the latent space and combined them and inserted those combinations over and over and again combinatorially into into the deterministic model. So I knew, and as you just pointed out, I knew that there was a there was a frequency problem. So the frequency term in the deterministic equation, as physicists we know, is in this presentation somewhere. We inject adjustments to that frequency thing, right? Okay, and eventually, by using some combination of the latent space, you come up with a correction that matches, it makes the deterministic model fit the actual observations.
That's cool.
Okay,
Yeah.
and because we have that deterministic equation already, and we know what constants, gravitational constant and length of pendulum, are in that frequency term, and we know how much we've adjusted it, we then know that something has to be wrong with our assumption, with our physics. It's pretty freaking cool. So either we have to change the gravitational constant, or we had something wrong about the length of our pendulum. So in this contrived example, we could say that we've learned something about the gravitational constant, or we've learned that we just had a bad experiment.
Right.
In which case you could fix that.
Right.
So that's pretty awesome, right?
Yeah.
And then just to wrap it up, the way that I made this happen is that my deterministic equation was based on small angle approximation, and the motion of the pendulum was not small angle.
I see.
Isn't that cool?
It's really cool. Yeah, it is. It's really cool. And yeah, it's exciting to think about where that could lead. Makes me immediately wish we had more actual laws governing geoscience.
less interpretation, or like, what do you mean?
Yeah, I guess so. Yeah.
And customers and loan officers and automated cars, and I mean all these things.
Wait, did you give 2 talks at this conference, or was that a previous year?
I actually gave 2 talks at this conference.
You are just unstoppable.
Yeah, so anyway, that's a really cool result. And in that talk, as you can find online, Matt didn't find it, or he found 2 of them. There are links to a bunch of the sort of factor analysis types of machine learning interpretability libraries, and there's a link to Lucid, which we mentioned before. But my mind is absolutely blown. I mean, to think that we could learn something about the physical universe, and whether that's physics or whether it's a business process. I mean, by perturbing latent spaces of deep learning models, I mean, that's next level. I mean, that is the next progression in human, not understanding, but discovery.
Yeah, discovery. It's a very interesting tool for discovery.
Yeah, because you can just let the computer just watch whatever's happening in nature.
Yeah,
and then see if that matches what you thought it should be matching.
Yeah, right.
Yeah, and then
yeah.
the beautiful piece though is that because it's quantitative now, you can change it.
Right.
You can investigate it.
Now, to what extent is that? Can you sort of codify that method of the meta exploration that you were doing, the decisions you're making? So, to what extent could you automatically search that space? And I guess it's
you can definitely do it for subsets of problems, and for subsets of those subsets which are computationally small.
Right. Okay.
I mean,
this
sounds,
method.
That sounds like an optimization problem.
Yeah. Right.
Exactly.
Right. Yeah.
Exactly. But this is only one method. I mean, this is completely different from, let's say, expanding your latent space and investigating which pieces aren't zero. It's totally different from what the Lucid folks are doing. So there are many methods. And yeah, this combinatorial optimization method is one.
Really, really interesting. So yeah, I hope the video is on there. If you search for Graham Gansel AI Summit Texas videos, you actually just get a bunch of some weird podcast undersampled radio. So I don't know if the video's up yet, but I hope it is, because I'd love to see the full expanded version of the talk with all of the appropriate GIFs and hand waving. It reminds me though that there was so that's a perfect segue to something that I know nothing about, which is a paper that came out very recently, like a week ago or so. It's what was the name of the author? Reichstein et al. In Nature, about deep learning and discoverability of natural laws in geoscience specifically. So yeah, definitely worth checking out if you're into earth science and machine learning. I'll drop the link into the show notes if and when they exist, but Reichstein et al. Nature, February 2019, you should find it pretty quickly. And it is behind a paywall. You can read the first page for free, but I expect many of you will be able to discover it. And if not, can write to the authors, or you can probably think of someone who has a copy of the PDF who could potentially share it with you in an entirely legal way.
What legal way is that?
Slack. It's just, fair use copying.
No comment. That's the end of our show notes, folks. We're gonna let Diego. Never mind. I don't want to put you on the spot too badly. Instead, I would like you to ask Matt a question which is difficult to answer on air in real time to sign us off.
About anything.
Anything.
One that involves me talking about my t-shirt.
Oh wait, hold on. Yeah, before we go, so you think of a question while we talk about this. There's Undersampled Radio t-shirts, everybody. Yeah,
we got. So I was gonna put a few of them on the website, on probably Software Underground. I don't want to set up another store, so we won't do it on our website, but we'll do it on the Software Underground website. I don't know about the white one. I
think the white one looks cooler, but I can't wear white t-shirts because I get them dirty in 30 seconds. And
the cotton's really nice.
Yeah,
very good. So yeah, anyway, Diego.
So Matt, what do you think happens inside the event horizon of the black hole?
Yeah.
Yeah.
Nice.
Well, isn't it the spaghetti thing?
What is the spaghetti thing?
Don't you get drawn out into an infinitely long piece of length of matter, energy?
Oh yeah, I'm hungry. Let's go get dinner.